Choosing a programming language is the most important decision of your life. Once you've chosen your cult, you can never change your opinion, and you will be barrel-stuffing Kool-Aid for the rest of your career. I am stupid, so I need a language that prevents as much foot gunning as possible. Preferably, I need things like immutability, null safety, robust types, exhaustive switch cases, brainless error handling, tooling that holds my hand, and code that's easy to read and write. A lot of modern languages have these features. And since I couldn't pick one, I'm going to build the same application in 10 of them, including Rust, Crystal, Julia, Go, Nim, Zig, Gleam, Dart, Kotlin, and Swift. In the process, you'll learn the trade-offs between each of these languages so that you can make the best choice for your next project. And just for fun, I'm going to give each language a 1 to 5 rating in the categories of tooling, safety, readability, and ergonomics. The first thing we'll do is build a simple TCP server with no dependencies in Go. Go is a language that prides itself on being simple. There is no nonsense, nothing flashy, and it gets the job done. We start by creating a new TCP socket on port 8001. First thing you may notice is that errors are stored as values and have to be handled explicitly. The LSP forces you to acknowledge these errors. Usually, this is done by asserting they are not nil. There is no null safety in Go, and the type system is not advanced enough to enforce that only one of listener or error is currently present. This makes for a less safe but a simpler language. Personally, I don't like this method of error handling. It feels like handling errors is a chore that will pollute my code, not something that I can do gracefully. The TCP socket takes 3 commands. Exit just closes the socket, name returns the name of the current language, and process passes a file, processes the data and saves 2 files as output, one with a cleansed data set and another one with some statistics. More on that later. Reading a file, you can see that the standard library includes all the functions you'd expect for accessing the file system and performing string manipulation. It is missing some functions that you normally use for functional programming, like map, reduce, and fold. We create a transactions array, and then loop through all the lines to populate it with the transactions. This pattern is very common in Go. We also create a couple functions to save data to some output files. Here's what the data that we process looks like. We have a list of transactions with a date, customer ID, product ID, quantity sold, and price per unit. We save a statistics object with a total, mean, median, and mode. The cleanse function takes a list of transactions, standardizes the date format by manually converting the string, removes any duplicates, and then sorts the list by date and customer ID. The final function is one used to calculate statistics. Once again, this is done using the same simple building blocks. We loop through the transactions and save some values for each of the statistics we need. You can see here that Go is not immutable by default. The tooling in Go is a pleasure to use. It just worked out of the box and never gave me any issues. Go is not much fun, but that is by design. It aims to be boring in a good way, and it is a great language for getting stuff done. I gave Go the following scores out of 5 for my chosen categories. I hope that avid Go fans won't have an aneurysm because the language is meant to be mundane. It's not trying to score highly in all of these categories. Crystal is the exact opposite of Go in many ways. It's a little wacky and fun. It's not quite like the other girls, and it's very expressive and succinct. If you've used Ruby, which I haven't, it's kind of like that with type safety and way shittier tooling. Compared to Go, spinning up a TCP server is already more succinct. Too bad it was twice as hard to write because the LSP didn't even work at all. I actually put off finishing Crystal for a long time and ended up doing it last because none of the tooling worked for me. While investigating online, the best solution I could find was people recommending to just use the Ruby toolchain since it works kind of pretty good with Crystal. The code for loading a file is also much shorter. The standard library includes a mapping function so I can just return the transactions directly. This makes the code a lot easier to read and write, and less error prone since we don't need to make mutable variables. If the data is invalid, we throw an error by using the raise keyword. Error handling in Crystal uses unchecked exceptions. This is a big no-no for me because I'm lazy as fuck, and unless the compiler forces me to, I'm just going to let my program crash instead of handling errors. Mapping functions also make writing to files much simpler. Crystal has a very nice convention where functions that mutate finish with an exclamation point and functions that return a boolean finish with a question mark. I'm assuming it stole this from Ruby, but once again, I didn't use it, so I don't know. For example, sort without an exclamation point will return a new list, but sort with an exclamation point will mutate the data directly. Functions can also be called without parentheses when there are no parameters. I really like this. This makes for cleaner code from the caller's side, since a function with no parameters is the same as a value from the caller's point of view. It also has trailing lambdas, which are super underrated, and it lets you write if statements as expressions. Some of the syntax is inconsistent though. Sometimes you use curly braces, sometimes you have to do end, and most of the times you can just use either. One thing I found very strange is the way private parameters are automatically declared, but if you want something to be public, you have to add the property syntax. Crystal is very strict about whitespace as well, so you must have a whitespace before and after the colon when declaring types. This really made my eyes hurt. Crystal was surprisingly easy to write, even with no syntax highlighting or LSP. It was a nice little language that I enjoyed writing, but it definitely seemed like the type of language where there would be a lot of magic, and where reading code is so hard that you may as well start from scratch whenever you need any new major features. Kind of like Ruby, which I still haven't used. Kotlin is a language that is built to be a successor to Java. It's a very robust and reliable language, and it fixes a lot of what Java got wrong. But it's maintained by JetBrains, whose main source of income is selling IDEs, so there's no first-party LSP, and unless you're using IntelliJ, the tooling is kinda shocking. The TCP socket in Kotlin is much more verbose than Crystal. This is because we have to lean into the Java ecosystem to get the needed functions. Kotlin does come with some really nice utility functions though. You can see the .first and .last functions, which get the first and last word in a split respectively. We are also using an exhaustive when statement, which is safer because it forces you to handle all cases. Kotlin also uses unchecked exceptions, which are inherited from Java. I would much prefer errors as values. Kotlin is immutable by default using the val keyword. Loading a file, we can start to see why Kotlin is such a pleasure to write. We can chain the split directly into a map function and return a list of transactions. The conversion to integers is also very ergonomic. When writing to a file, the standard library has a very nice join to string function, which joins the strings and puts the separator in the middle. This makes formatting the file as simple as it could possibly be. I really enjoyed writing some extension functions to simplify the cleanse function, and the existing compare by function makes sorting the simplest out of all the languages. The story continues in the calculate function. The standard library has some great functions like group by, map, sum of, and coerce at least. I don't even think I bothered to handle the divide by zero case in any of the other languages. I just did it here because it was so convenient. It is these functions that make Kotlin such a pleasure to write. The library is built to make functional programming effortless. I'm sad I can't use Kotlin in whatever editor I want, and I'm sad that it still lives with some of Java's mistakes. But it's a really nice language, and I'll probably always use it in some capacity. Swift is more than just the language used in Xcode. It is a powerful and expressive language that can be used for general purpose programming, and even Apple ships an LSP with Swift. You know you've gone wrong when Apple has better third-party tooling than you. The error handling in Swift is an excellent implementation of exceptions. Swift uses exceptions, which I usually wouldn't like, but they give you all the tools you need to handle them in a nice way. Functions are forced to identify when they may throw an exception, and the caller is forced to acknowledge all exceptions. The language also provides some nice syntax to either convert the exception to a null using try question mark, bubble the exception up using a regular try, crash the whole program using try exclamation point, or manually handle it using a traditional try catch block. This last option was the only one I didn't like. It felt like there was a nicer way this could have been done, especially when all the other options are so neat and easy. The tooling was mostly good. I ran into some issues where the LSP couldn't identify dependencies. I'm either the first person to use Swift with NeoVim or the first person to encounter this particular issue, because I could not find a fix for it anywhere. Swift was one of only 2 languages where I even had to use an external dependency at all. Swift itself cannot create a TCP socket without writing some Objective-C. Because Swift is first and foremost a language for Apple products development, some things that should be simple aren't really that obvious. Searching for help is hard because not many people are using Swift for general purpose programming. The loading function is very simple. You can see the named arguments making this very easy to read, and we're also forced to provide defaults when converting for a string to an integer. Saving to a file requires an extra function call to get the URL, but other than that, it's pretty similar to the other languages so far. I was impressed by how versatile Swift is. The data handling was very easy to write. It includes some utility functions like reduce and max, which I found useful when calculating statistics. Overall, I really liked Swift. It felt like Kotlin with some better error handling, but a worse standard library and slightly better tooling. Zig is one of the most promising languages I tried. I really wanted to like it, but I just didn't have a good time. It's one of only 2.5 half languages that aren't garbage collected on this list. It aims to make memory management easier by giving you better tools, which I think is a great concept. Starting a TCP server in Zig is just as simple as in any of the other languages I used. Memory management is done using allocators. Zig has different allocator types that can be passed around and used to manage memory. For example, in the process command, I create an arena allocator. This is an allocator that will free all the memory it was used to allocate when itself is cleaned up. I use the defer keyword to clean up the allocator at the end of the current scope. Now, we can pass the arena allocator to all the calling functions and easily allocate memory on the heap, knowing that it will be deallocated when the command is finished. This is a great middle ground. You're still in charge of managing memory yourself, but you have some better tools to do it in a safer way. The problem is that you still have to learn about all these different allocators and such, but the documentation and tooling isn't all that helpful. This is mostly a skill issue, but it's an issue nonetheless. You can also see that the string manipulation functions are very verbose and clunky. There are no strings in Zig. Everything is an array of U8s. This was actually the most frustrating part to work with. I really like the error handling in Zig. You can mark the return type of a function with a question mark if it may be null, or an exclamation point if it may be an error. The calling side uses a try syntax to bubble the error up. Just like in Swift, I really like this syntax since it makes it immediately clear what functions may error. Functions like sort act in place by default. This results in more performance but less safe code. LSP diagnostics didn't always work, and the rest of the LSP still wasn't all that helpful. The compiler felt like my enemy rather than my friend. Some of the error messages felt like nonsense, and some of the stack traces wouldn't even point to my code at all sometimes. Do you know what this error means? I solved it and I still don't know what it means looking at it right now. I'm pretty sure it has something to do with a null type, but I'm honestly not even sure. Like I said, I really want Zig to do well, and parts of it I really enjoyed using, so I'll always be watching this space. A simple language with manual memory management and no header files would be so cool, but it's not quite there yet. Gleam is a language built on top of a Beam ecosystem. It is very opinionated and very functional. Even just spinning up a TCP socket, it's already different. And surprisingly, it felt pretty good to write the handling first and then pipe it into the server. Since Gleam is built on top of an existing ecosystem, the standard library doesn't provide any code for reading files or starting a TCP socket. It is the only language other than Swift where I ended up using external dependencies. Gleam has errors as values, and the error handling is rock solid. It forces you to handle all errors and provides good utility functions for doing so. The problem is that there's multiple ways to handle errors, and you have to know which one is best for your current situation. I know that this isn't the best way to do this, but I could not be bothered figuring out how to do it correctly. It's a skill issue, but it's an issue that doesn't exist in other languages. For example, when loading the file, we use this use backwards arrow syntax to either get the value or return an error. And instead of a regular map, we use a try map, which will return an error if any of the values are an error. This isn't trivial, and it's a new skill to learn, but it feels more correct when you actually do it properly. I also want to mention that Gleam is the only language that forced me to handle an out-of-bounds error when accessing an array. Gleam is by far the most opinionated language I've ever used. For better or worse, it told me what I needed to do, and there was no other option. I asked if I could have an if statement, and Gleam gave me a backhand and told me to stop asking stupid questions, and that I should use something that handles all clauses instead. And when I was looking for a way to find the length of an array, the documentation low-key insulted me and implied that I was a bad programmer and that I probably shouldn't be doing that anyway. And it hurt my feelings. But you know what? When I was done crying, I realized I liked the patterns that it was forcing me into. The code felt cleaner and made more sense. It's a functional language that is really good at doing real-world stuff. Writing algorithms and solving problems is really fun. You can break down your problems into steps and just pipe your values all the way through. A lot of things just make sense in Gleam. It felt like there was a lot of thought put into the little things, and it was a pleasure to use. But because it forces you into certain patterns, some things are just harder than in normal imperative languages. This is the kind of language that I would love to use for Advent of Code, but I would spend 2/3 of my time passing the fucking file. The LSP wasn't amazing either. There were some points where it was completely useless, and the string formatting when printing was completely ass. I feel like I've undersold Gleam a little bit here. It's really nice, and it was one of my favorites. It just takes some getting used to. Going from Gleam to Nim felt like getting punched in the gut. Not because Nim is especially bad, but because it had no idea what it wanted to be. If Gleam was the most opinionated language I've ever used, Nim was by far the least opinionated. Nim includes result types in the standard library, but it also includes the syntax for throwing exceptions. Looking at a style guide, the advice I saw was prefer result types, but be careful because most of the standard library uses exceptions. Nim is garbage collected by default but you can disable the GC and use memory management. But once again, the standard library would stop working because it relies on the GC. Anyway, spinning up a TCP socket was very simple, pretty much on par with the other languages. And file manipulation was also very simple. The standard library has some nice functions that can be used to split, map, and join the data. It has immutability, but like I mentioned, its main error handling is unchecked exceptions. I still don't understand who the target audience is for NIM. Is it meant to be a replacement for Python? If it were just a faster Python without a GC, then I'd really see the point. But right now, I just don't see the advantages. I still have to deal with white space, and it's clean and succinct, but I don't know if it's cleaner and more succinct than Python. I'm sure there's a brilliant language in here somewhere. I'm just forced to figure out which bits of it I actually want to use. The tooling and documentation was surprisingly good for such a small language, and it really shows what can be done. But the lack of identity made it feel bland compared to the other modern languages. Dart is mostly known as the language that is used for Flutter, but much like Swift and Kotlin, it can also be used on its own, and it is a very nice language. It's missing some of the newer features, like for example, it isn't immutable by default and it still uses unchecked exceptions, but it's a very solid and simple language. Since it was built for the front end, it uses futures to handle asynchronous code by default. This is kind of like a JavaScript promise. In many ways, Dart is a more consistent and safer JavaScript. If you took JavaScript, removed the weird inconsistencies, and added prettier TypeScript and null safety, you would get something very similar to Dart. Except with Dart, you don't need all these NPM dependencies, and it's consistent across projects. Dart reminded me a lot of Go. It was so simple that it was boring. There was no exciting syntax or outstanding features. You just write your code and get on with your life. It does have some nice functions in the standard library that make it even easier to use than Go, like a mapping function and a joining function that I used when passing a file. There were a lot of things that impressed me about Dart. The tooling was some of the best I used. Everything worked right out of the box and I had no issues. The language is very nice and elegant. There's nothing shocking or offensive. It just works how you expect it to. Without any experience, I felt comfortable using it right away. I did have to create mutable variables for median because the if statements aren't expressions, but it was a very solid and simple language. I did not expect to like Julia, but it was the most surprising language I used. It was very easy to get into. The tooling was very good, but not perfect. It couldn't detect my external imports, and sometimes the LSP would break. To me, Julia felt like a language made for short scripts and data processing. Where it sets itself apart from similar languages is that it has a functional programming mindset. One thing you'll notice is that it uses unchecked exceptions. It also has dynamic typing by default, but it is very easy to add types when you want them. This is nice for quickly building the parts that aren't type sensitive, but taking the time to type the core data correctly. This does mean that some type-related bugs aren't caught early. For example, I had a runtime exception when converting a string to an integer. Some of the errors are also very unclear. Take a look at this error and tell me what you think it means. It was that I was exporting the transaction type incorrectly, so it couldn't find a function that matched this array of transactions. It just says method error instead of telling me what actually happened. I think I also have to mention this, but arrays start with 1. Julia was boring, but also in a good way. Everything was pretty good and nothing was awesome. I definitely prefer it over languages like Python, but I would only use it in specific scenarios, like a step up from Bash or quickly processing some local data. It's easy to see why there is so much hype around Rust. It gets a lot of things right. It's a very expressive language with a powerful type system and great error handling, and the fact that it has no garbage collector is a huge cherry on top. Looking at the TCP server, it's a lot more verbose than most other languages. Rust forces you to handle all errors, and it provides some good utility functions for doing so, but they do end up being more verbose than other languages. For example, depending on the situation, you may want to convert the error to a more specific one, or default to a certain value, or best of all, just put a question mark to bubble the error up. For the most part, Rust is a joy to both read and write. The only thing that holds it back is that there are some advanced features. This is kind of like error handling in Gleam. Depending on your expertise, you may write very different code. The same thing happened, where I know there's a more concise way to handle this, but I just don't know how to write it. And this is a skill issue, but it's a skill issue that doesn't exist in Go or Swift. You can run into skill issues a lot when writing or reading Rust. This will become a problem when you need to collaborate with other people or read really old code. To be fair, for the most part, you can make it look like other languages, so you can write basic code without struggling too hard. But once you're ready, it has some expressive features that that let you write concise and safe code very easily. Given the right problem, Rust can often be the best solution. It has its drawbacks, and I was lucky enough not to need lifetimes or multi-threaded or asynchronous code in this example, but it's an incredibly powerful language that deserves all the hype it's getting. There is something that needs to be said about the extra effort you take on board when writing Rust though. It is very expressive and very safe, but sometimes you can find yourself stuck on a problem that you're not used to solving. There are some projects where if it was 10% harder to write the code, the project would fail. And sometimes Rust can take 10% more effort to write. Anyway, Rust uses iterators to write functional code, which is a little more verbose since you need to add the iter and collect, but it works the same as you'd expect for the most part. It also has immutability by default and errors as values, as previously mentioned. I rated Rust very highly because it ticks all the boxes I mentioned at the start. There are still some situations where it was a little too verbose or too clunky for my liking though. Overall, I think that Rust is the best modern programming language, but it is also the hardest one. So unless you need to write code without a garbage collector, I prefer using something like Gleam or Swift. Here's how the language is ranked by each category. But I think I have a better way to categorize this data by splitting it into two categories. The first one is languages that are the best version of what languages have historically been. To me, these are very imperative and very simple. Go, Dart, and Nim fall into this category. They are rock solid languages. The second category is languages that include all the modern features I mentioned, like exhaustive switch statements, immutability, null safety, pure functions, clean error handling. These languages are more functional and expressive and prevent you from making a lot of common mistakes. Swift, Gleam, and Rust fit nicely into this category. Both of these types of languages suit different people. Some might enjoy the simplicity of Go, while someone else prefer the expressiveness of Gleam. They're just different ways to read and write code. I happen to prefer the latter, so my results are biased in that way. And now that you understand all these languages, you can go back to work where you're forced to use Java 8 and JavaScript to maintain 10-year-old code with no hope of ever using anything better. This video was a ton of work, so make sure to like and subscribe. And don't forget to tell me why I misrepresented or forgot your favorite language in the comments.